Hello, I'm Aaron Park, and this is 7th grade, lesson 23. So for our first problem, it's a word problem. There are 44 flowers in the flower garden. They are arranged in 6 rows. X flowers are in each row of 5, and 4 flowers are in the last row. What is the value of X? So we can see that there are 44 flowers total, and these flowers are arranged in 6 rows. However, 5 of the rows have X flowers, and the last row, one row, has 4 flowers. Using this, we can write out this equation. To quickly explain, 44 here is the total. Then we can set that equal to the sum of the parts. What are the parts? Well, as I was saying, there's one row of 4 and then 5 rows of X. Now we simply solve and isolate X. So if we first subtract this 4, because 4 times 1 is just 4, from both sides, we get 40 equals 5x. And now we divide by 5. The coefficient 5 cancels out. 40 divided by 5 is 8. X is equal to 8. The answer is C. Solve for x in the expression below and mark the correct answer. Now this is similar to what we just did, except the equation is given for us. And there's a couple of decimals, but decimals should be familiar to you at this point. So I'll let you solve this on your own. Number 3. 12 dogs and X cats together have 68 legs. How many cats are there? So 68 legs total from 12 dogs plus X cats. However, how many legs does each dog have? The answer is of course 4. And how many legs does a cat have? Again, it's 4. So now, just like the first problem, we simply solve for x. I'll let you finish this problem on your own. You can show your work, but the answer should be 5. And our final word problem, actually, there's a couple more. Number 4, Mr. Moody creates math test questions 5 days in a week. He works X hours every day except Friday, when he works 2.5 hours. If he works 22.5 hours per week, what is the value of X? So every week he works 22.5 hours. He works 5 days a week. However, he only works 2.5 hours on Friday, and the other 4 days, so probably Monday, Tuesday, Wednesday, Thursday, he works X hours. If we solve by subtracting this 2.5 from both sides and then dividing by 4, we get X equals 5. 5 hours. Let's skip down to this section, some different types of problems. Now these are inequalities. We'll first do the first one. Solving inequalities is just like solving equations. We want to isolate the variable, so we divide by the coefficient. Cancels out, and then we get p is greater than or equal to 7. For number 2, you're introduced to the one thing that's a little bit different about inequalities. Let me just rewrite this so it's easier to see. We have this. The obvious step is we multiply both sides by -3. So these -3's cancel out, and then this right side turns to 30. All is well and good, but there's one important thing. When you divide or multiply by a negative number, the sign flips. So instead of less than, it will be greater than. X is greater than 30. And our final answer is this. It is not x is less than 30. So to reinforce that, if we look at 3, -6y is less than -36. Divide both sides by -6. The coefficient cancels out. -36 divided by -6 is 6. So y and 6, and this sign flips. So this is our final answer for 3. We we go through the others. For 40, 40 is greater than y over w over 5. Multiply both sides by 5 to get 200 is greater than w. For q, once again, multiply both sides by 4 to get q is less than 28. And then for the last one, divide both sides by 9 to get 8 is less than or equal to r. For these two, you can rewrite them so that the variable is in front. Just make sure that the sign makes sense. 200 is greater than w, so w is less than 200. Similarly, r is less than or equal. Sorry. R is greater than or equal to. Now, let me review this negative concept because it's the one tricky thing about inequalities. I will quickly prove or explain why this occurs. So, let's look at this number 2. If we did not switch the sign when we multiplied, we would get this. X is less than 30. Now, let's check if this is true. To do so, we simply plug in a number that is true for this. For example, a number that's less than 30 is 0. 0 is less than 30, yes. Let me write this over here. 0 is less than 30, so we'll be plugging in 0 into our original equation. So, is 0 over negative 3 less than negative 10? This simplifies to, is 0 less than negative 10? And the answer is no. This is wrong. If you look at a number line, 0 would be around here, and negative 10 will be here on the left of it. 0 is greater. So, since this is not true, this is not correct, this is not correct. Now, let's see what happens if we were to do as we should and switch the variable, or switch the sign. Greater than, then a value that's greater than 30. How about 31? Or actually, how about 33, so that it divides easily? 33 is greater than 30. Now, instead of 0, we have 33. Let me write it down here. Over negative 3 is less than negative 10. 33 over negative 3 is negative 11. And is negative 11 less than negative 10? The answer is, of course, yes. So that means this is correct. And that is why we changed the sign. Alright, that is all for today's lesson. Thank you.